Hello, welcome to CM Square Learning Center. In today's chemistry lesson, I'm going to focus on these two questions, MC questions for topic 4, bonding and structure, and mainly for metallic bonding. So the first question asks you the definition of metallic bonding, where the second question is to examine the factors affecting the strength of metallic bond. So let's look at the first questions. Zinc metal contains metallic bonding. Which is the best description of metallic bonding? So as we know, metallic bonding, the definition is the electrostatic attraction between the cation, the metallic cation, the metal cation, right? And the delocalized electrons. Or let's say there's a piece of metals, and the metal ion is surrounded by the sea of delocalized electrons. And the key thing is that it's non-directional. So that's the metallic bond, the electrostatic attraction between the metal ion and the delocalized electrons. Oh, sorry, not this one. Yeah, like this. So let's look at all the four choices. The first one, the electrostatic attraction between a pair of electrons and positively charged nuclei. So we see electrons and nuclei. It seems that it's very close to the answer, right? Let's look at the rest of the choices first. We have to eliminate all the wrong options. B, the electrostatic attraction between oppositely charged ion. So that is definitely wrong, because that's the definition of ionic compound, ionic bonding. Ionic bonding is the electrostatic attraction between the positive charge ion and the negative charge ion, or you can say cation and anions. Yeah. So C, the electrostatic attraction between a lattice of positive ions and delocalized electron. Yeah, I think that's the answer. Yeah, because we see all the keywords. Positive ion, that's the metal ion, and delocalized electrons. Alright, last one, D. It should be wrong, right? The bond formed when one atom provides both electrons in a shared pair. So yeah, that's wrong, because one atom provides both electrons in a shared pair is like the dative covalent bond. It's not a covalent one, because it mentions one atom provide. Okay, it's not two atoms sharing electrons to form a bonding pair. Okay, the bonding pair is from one single atom. Okay, that's a dative covalent bond. Okay. So the answer is C. Okay, the second one. Which metal has the strongest metallic bond? So as we know, metallic bond is the electrostatic attraction between the metal ion and the delocalized electrons. Like this. So there are two factors affect the strength of metallic bond. The first one is the size of metal ion. The second one is the charge of metal ion. So to be a stronger metallic bond, that means the two oppositely charged species must be as close as possible, right? Closer, they will have a stronger metallic bonding. So smaller size of metallic ion, stronger metallic bonding. And the second one is the charge of metallic ion. So higher charge have a stronger attraction with the delocalized electron. So the charge increasing the metallic bond, the strength. So yeah, so two things, key things. Smaller size or higher charge with a stronger metallic bond. Alright? So let's look at these four choices. Li, Na, K, and Rb. So these four metals are all group 1 metal. Here. All these four. So let's look at the factor one by one. Because they are both group 1 metals, so the charge of the metal ion is all 1 positive. So we can ignore the second factor, the charge of metal ion, because they are all the same charge. So will be no effect. And so that means we have to look at the size of metal ion. The small size of metal ion with a stronger metallic bonding, so we have to choose the one with a small size. The size of they are actually increasing down the group. So that means lithium has the smallest size of metal ion, right? So yeah, the size will be smallest, so it will have the strongest metallic bonding.